Hello there and welcome back. So in the next few videos we're going to start introducing with dependency injection, and we're going to read the official Android documentation together. So before we go into our official documentation, I want to read you the actual definition of dependency injection. So Wikipedia says, in software engineering, dependency injection is a technique in which an object receives other objects that it depends on, and these objects are called dependencies. So this is an important definition, and it's very simple and basic. So now I'm going to open up official Android developer documentation, and we're going to read together this overview section for now in this video. And I know that official documentation sometimes can be boring, but still it's one of the best places to find different information about Android in general. Also, this documentation contains a few useful examples, and I just love reading this official documentation. Whenever I visit some new document here, I always rate this document 5 stars because it's very helpful. Okay, so let's start reading together, okay? So dependency injection is a technique widely used in programming and well suited to Android development. By following the principles of dependency injection, you lay the groundwork for a good app architecture. And implementing dependency injection provides you following advantages: reusability of code, ease of refactoring, and ease of testing. So what is dependency injection? Well, in this section we're going to see one example of a car and engine. And that is a very nice example of object-oriented programming. So classes often require references to other classes. For example, a car class might need a reference to an engine class, and these required classes are called dependencies, okay? And in this example below, the car class is dependent on having an instance of an engine class to run. So there are 3 ways for a class to get an object it needs. So the first one, the class constructs a dependency it needs, and in the example above, a car would create and initialize its own instance of engine class. The second one is grab it from somewhere else. For example, some Android APIs such as context getters and get system service work this way. And the third one, have it supplied as a parameter. And the application can provide these dependencies when the class is constructed, or pass them in the functions that needs each dependency. In the example above, a car constructor would receive engine as a parameter. And this third option is actually dependency injection, okay? Because we are injecting our dependency in a constructor of our car class. So down below we can see one example without a dependency injection. So in this case, as you can see, we have a car class, and inside our car class we are constructing our own engine class, and then we are using this function to call this engine to start it. So this is not an example of dependency injection because the car class is constructing its own engine, and this can be problematic in 2 ways. So car and engine are tightly coupled. An instance of car uses one type of engine, and no subclasses or alternative implementations can easily be used. So if the car were to construct its own engine, you would have to create 2 types of a car class instead of just reusing the same car for engines of a type gas and electric, for example. And the second one, the testing is more difficult without this dependency injection. So down below we can see a new example of how it should look like with dependency injection. So as you can see, we have a car class, and inside our constructor we are injecting this engine class, and we are just using this function to actually start this engine, okay? And inside this main function, first we are initializing the engine, and then we are passing that engine inside parameters of this car class, and then we are just starting the car, okay? So this is how it should look like with dependency injection. So the main function uses a car, and because car depends on an engine, the app creates an instance of engine and then uses it to construct an instance of car, okay? So the benefits of dependency injection based approach are reusability of car, so you can pass different implementations of an engine to a car, and you don't need to construct multiple car classes. You can just create multiple engines which basically inherits this base engine, and you can just pass them into our car class or inside a constructor, of course. And the second benefit is easy of testing, of course. So there are two ways of doing dependency injection. The first and most used one is a constructor injection. You just pass dependencies of a class to its constructor. And the second one is a field injection or a setter injection. So certain Android framework classes such as activities and fragments are instantiated by the system itself. So a constructor injection is not actually possible. And with those cases, we use a field injection, where dependencies are instantiated after the class is created. And down below we can see one example. So as you can see, inside our car class, we are using a field injection, and we are using a late init keyword. And then inside our main function here, we are instantiating our car class, and then we are instantiating our engine. Because without instantiating this engine, we would not be able to start the car, okay? Alright, so let's scroll down below. So in the previous example, you created, provided and managed the dependencies of the different classes yourself without relying on a library. And this is called actually a manual dependency injection. So in the car example, there was only one dependency, but more dependencies and classes can make a manual injection of dependencies more tedious. And also manual dependency injection can present several problems. For example, for big apps, taking all dependencies and connecting them correctly require large amount of boilerplate code, and in a multi-layered architecture, in order to create an object for a top layer, you have to provide all dependencies of the layer below it. So for example, to build a real car, you might need an engine, a transmission, a chassis and other parts, and you would need to instantiate them before you actually initialize a car object. And the second one, when you are not able to construct dependencies before passing them in, for example, when using a lazy initialization or scoping objects to flows of your app, you need to write and maintain a custom container that manages the lifetimes of your dependencies in memory. And there are already made libraries that solve this problem by automating the process of creating and providing dependencies, and they can be separated in two categories. The first one is reflection based, and the second one is a static solution that generates the code to connect dependencies at a compile time. And you might have heard already about a Dagger library, and that's a popular dependency injection library for Java, Kotlin and Android maintained by Google. And it provides a fully static and compile time dependencies addressing many of the development and performance issues of reflection-based solutions such as Goose. And if you're wondering if there are any alternatives to dependency injection, there is. And in the past, most developers used the service locator to handle dependencies, and this service locator design pattern also improves decoupling of classes from concrete dependencies. So this is kind of upgrade from manual dependency injection. And for example, you create a class known as a service locator that creates and stores dependencies and then provides those dependencies on demand. So for example, we have a singleton service locator, which contains an engine here, and then inside our car class we would call this service locator singleton, and then we would call this get engine function to actually instantiate it, okay? So this service locator pattern is different from dependency injection in a way that elements are consumed. So with the service locator pattern, classes have control and ask for objects to be injected, and with dependency injection, the app has control and proactively inject the required objects. So compared to dependency injection, the collection of dependencies required by a service locator makes code harder to test. Then dependencies are encoded in the class implementation, not in the API surface, and as a result it's harder to know what class needs from the outside. And managing lifetimes of objects is more difficult if you want to scope to anything other than the lifetime of the entire app. And with a Hilt dependency injection library, we have pre-made scopes for managing different kind of life cycles for activities, fragments, services and so on. And of course in this course we are going to use a Hilt dependency injection library, and Hilt is developed and managed by Google. So Hilt defines a standard way to do a dependency injection in your application by providing containers for every Android class in your project and managing their lifecycle automatically for you. So Hilt is built on a popular Dagger library to benefit from compile time correctness and runtime performance, scalability and Android Studio support that Dagger provides. So I know that sometimes reading this documentation can be a boring job, but still I always recommend you to read this official documentation, because you might find some good examples and some detailed information about each and every topic there is. So that will be all for this video. So in the next videos we're going to read this manual dependency injection section here, and also you're going to see some great examples here, and how actually hard it is to manage dependencies manually by hand. And after we read this manual dependency injection documentation, only then we're going to read the documentation about the Hilt Android library, and we're going to get introduced with that library as well. So when we finish reading all of those documentation, you will be able to continue and do dependency injection with the Hilt library by yourself. Hello there and welcome back. So in the previous video we went through dependency injection overview documentation together, and in this video we're going to go through this manual dependency injection documentation and get familiar with how hard it is to keep and maintain dependency injection manually by hands. So let's get started, okay? So here it says that Android recommended app architecture encourages dividing your code into classes to benefit from a separation of concerns, a principle where each class of the hierarchy has a single defined responsibility. And this leads to more smaller classes that need to be connected together to fulfill each other's dependencies. So down below we can see one application graph, and here, as you can see on the top, we have a UI activity or fragment. Then our activity or fragment depends on a view model, then view model depends on a repository, and the repository depends on a local and remote data source. So our application graph in this course looks very similar to this one. So dependencies between classes can be represented as a graph in which each class is connected to the classes it depends on. And the representation of all your classes and their dependencies makes up the application graph. So this is an application graph, and when a class or a view model depends on a B class or repository in this case, then there is a line that points from A to B representing that dependency, okay? Alright, so dependency injection helps make these connections and enables you to swap out implementations for testing. Okay, so now we're going to read the basics of manual dependency injection. So they say that this section covers how to apply manual dependency injection in a real Android app scenario. It walks through an iterated approach of how you might start using dependency injection in your application, and this approach improves until it reaches a point that is very similar to what Dagger will automatically generate for you. So first we're going to get familiar with manual dependency injection, and then we're going to see a slightly improved example of dependency injection with a container, and after that we're going to see some more improved examples with application flows. And when we reach that third section will be basically similar to what Dagger will automatically generate for you. So you will see that at the end of this video. And consider a flow to be a group of screens in your app that correspond to a feature. So login, registration, and checkout are all examples of flows. So down below we can see some example of that. So when covering a login flow for a typical Android app, the login activity depends on a login view model, which in turn depends on a user repository, and then user repository depends on a user local data source and user remote data source, which in turn depends on a retrofit service. And here you can see one application graph. So as you can see, this activity depends on a login view model, then login view model on a user repository, and user repository depends on those two data sources. And down below we can see some examples. So login activity is the entry point to the login flow, and the user interacts with the activity. Thus, login activity needs to create the login view model with its all dependencies. So down below we can see some examples of how a user repository should look like, and those data sources as well. So in this example here we can see that local data source and remote data source are injected inside this user repository, and our user remote data source is injecting this login service as well. And down below we can see the whole activity, so you can check it out and see how a manual dependency injection actually looks like, and there is a lot of boilerplate code. So we can see that this is a simple activity, And inside onCreate method here, we have first initializing a retrofit builder here. So in order to satisfy the dependencies of a login view model, you have to also satisfy dependencies of all its dependencies recursively. So first we need to create a retrofit, which is a dependency of a user remote data source. And then, as you can see, we need to satisfy dependencies of a user repository. And by that, we are initializing those two data sources. And then inside this user remote data source, we are passing this retrofit instance. So there is a specific order which we need to follow here. So first we need to define a retrofit here and initialize that, so we can actually pass it in our user remote data source, okay? And after that, you can create an instance of a user repository that login view model needs. And as you can see, now we have used those two data sources to inject them into our user repository. And lastly, as you can see, we are creating an instance of a login view model with this repository. So down below you can see that there are a few issues with this approach. So there is a lot of boilerplate code first. So if you wanted to create another instance of a login view model in another part of the code, then you would have a code duplication. So for example, if you want to use a login view model inside a different activity or fragment, then you will need to repeat all of that to satisfy this login view model dependency. Second, dependencies have to be declared in order. So you have to instantiate a user repository before login view model in order to create it. And you need to follow that order. So first you need to initialize a retrofit, then pass that retrofit in a user remote data source, and only then use those two data sources to inject them inside the user repository, and lastly in a login view model as well. And the third one, it's difficult to reuse objects. So if you wanted to reuse a user repository across multiple features, you would have to make it follow the singleton pattern, and the singleton pattern makes testing more difficult because all tests share the same singleton instance. So down below we have a second section in this documentation, so managing dependencies with a container. So this is a slightly improved example from the previous one. And to solve the issue of reusing objects, you can create your own dependencies container class that you use to get dependencies. So all instances provided by this container can be public. In this example, because you only need an instance of a user repository, you can make its dependencies private with the option of making them public in the future if they need to be provided. So you can see that here we have a simple class named app container. And you can see that here we are initializing our retrofit builder here, then two data sources, and only then we are initializing our user repository. And you can see that all our dependencies before user repository are actually private, because we only need the user repository to be exposed. Okay. So because these dependencies are used across the whole application, they need to be placed in a common place all activities can use, the application class. So you need to create a custom application class that contains an application container instance. So here, as you can see, we have created a simple class named myApplication, and this class needs to extend application class, okay? And after that, you would also need to specify a name attribute inside application tag in Android manifest file. So that's an important step to do, of course. And inside this myApplication class, we are basically instantiating our application container. And from here, this application container will be used across our application lifecycle. So application container is just a regular class with a unique instance shared across the app placed in your application class. Okay, so let's see some more examples down below. And here we have an example of our activity. So now we can see that there is no that much boilerplate code like in the first example. And now from here you can get the instance of application container. And as you can see, we don't need to specify those data sources and retrofit in order to satisfy our login view model dependencies. Instead, we can just get the reference of our app container and then pass our app container.user repository, okay? Because we have already defined how to initialize those dependencies inside this app container class. So in this way, you don't have a singleton user repository. Instead, you have application container shared across all activities that contain objects from the graph and creates instances of those objects that other classes can consume. So if login view model is needed in more places in the application, having a centralized place where you can create instances of login view model makes sense. And you can move the creation of a login view model to the container and provide new objects class of a type with a factory. And here is how it should look like with a factory. So here we're defining just a basic interface named factory, and down below we can see a class named the login view model factory, which implements this same interface from above. And here, as you can see, this login view model factory is injecting user repository, and then inside this create method we are just returning a login view model with this dependency as well. And down below we can see that you can include the login view model factory in the application container and make the login activity consume it. So here, as you can see, inside our app container we have created a new variable named the login view model factory, and here we have initialized this login view model factory, and we have passed this user repository, which is already inside this app container. And then inside this activity we are just initializing our app container, and from that app container we are getting this login view model factory, and we are creating an instance. So this approach is better than the previous one, but there are still some challenges to consider. So you have to manage app container yourself, creating instances for all dependencies by hand. And the second, there is still a lot of boilerplate code, and you need to create factories or parameters by hand, depending on whether you want to reuse object or not. And finally, we have our third section, which improves dependency injection a little bit more than those two previous examples. So app container gets complicated when you want to include more functionality in the project. So when your app becomes larger and you want to introduce different feature flows, there are even more problems that arise. So first, when you have different flows, you might want objects to just live in the scope of that flow. For example, when you're creating a login user data, you don't want to persist data from an old login flow from a different user. You want a new instance for every new flow. And you can achieve that by creating a flow container objects inside app container, as demonstrated in the code down below, which we're going to check it out. And second one, optimizing application graph and flow containers can also be difficult. So you need to remember to delete instances that you don't need, depending on the flow you are in. So imagine you have a login flow that consists of one activity, a login activity, and multiple fragments like a login user fragment and login password fragment. So these views want to first access the same login user data instance that needs to be shared until the login flow finishes, and the second, create a new instance of a login user data when the flow starts again. So you can achieve that with a login flow container. This container needs to be created when the login flow starts and removed from memory when the flow ends. So you want to be able to create multiple instances of a login container in the app. So instead of making it a singleton, make it a class with the dependencies the login flow needs from app container. So here we can see a new class named the login container, and we are injecting a repository here, user repository. And down below we are initializing our login user data, and of course we have a login view model factory here. And now our app container contains this login container. So login container will be null when the user is not in the login flow, and that's why we have set our login container to be nullable. So once you have a container specified to a flow, you have to decide when to create and delete the container instance. And because your login flow is self-contained in an activity, in this example login activity, then the activity is the one that manages the life cycle of that container. And the login activity can create the instance in onCreate and delete it in onDestroy method. So here we can see that our login container is initialized inside our onCreate method, and we are manually deleting the instance of that login container inside onDestroy method. So you can see how hard can it be to manage and handle all dependencies by yourself. It might be not a problem when you're working with only few dependencies, but when your application grows, it becomes a lot harder and tedious job. But don't worry, most of this code can be automatically generated and managed by a dependency injection library like Dagger or Hilt. And in the next video I want to show you just the basics of Dagger dependency injection library. And in the video after that we're going to get introduced with a Hilt library instead. But of course, before that, we're going to get introduced with a Dagger, just so you can see some slightly differences between Dagger and Dagger Hilt. So I know that this can be a lot of information for you to process, especially if this is the first time you're encountering dependency injection. But don't worry. After we get over with this theory and reading this documentation, we're going to start implementing dependency injection inside our application, and you will see in practice, and everything will make more sense to you. Hello there, and welcome back. So in the previous video we have read together documentation for manual dependency injection, and in this current video I want to just go through this Dagger basics documentation, which is very short, but still I just want to go through this documentation together with you. And after this video we are going to read dependency injection with HILT documentation, but also I can advise you to read this using Dagger in Android apps documentation as well before the HILT library, but I'm not going to cover that because I know that it can be boring to record more videos about it. So I'm just going to read through this Dagger basics documentation, and in the next video we're going to start with dependency injection with HILT. So this is a short document, so don't worry. So here it says that manual dependency injection or service locators in Android app can be problematic on the size of your project. So you can limit your project's complexity as it scales up by using a Dagger library to manage your dependencies. And Dagger automatically generates code that mimics the code you would otherwise have handwritten, because the code is generated at a compile time. It's traceable and more performant than other reflection-based solution like a Goose. So basically Dagger is built to fix manual dependency injection problems, and the Dagger HILT library is built on this Dagger library to reduce complexity even more. So here it says that you should use HILT for dependency injection on Android, because HILT is built on top of Dagger and it provides a standard way to incorporate Dagger dependency injection into an Android application. So there are a few benefits of using Dagger, and they are very important and useful. So Dagger can free you from writing tedious and error-prone boilerplate code by generating the app container code or application graph that you manually implemented in the manual DI section, and we have already read that section, so you know how tedious job can be to implement that by yourself. Also Dagger is creating factories for the classes available in the application graph, so this is how dependencies are satisfied internally, so we don't need to write those boring factories for each dependency there is. This is a big plus as well. Next, Dagger is deciding whether to reuse the dependency or create a new instance through the use of scopes. And we're going to talk about scopes even more inside dependency injection with HILT documentation. And you can see how you can create just one instance of, for example, a retrofit builder dependency and use it in a scope of your whole application. And that way you can increase the performance of your application in general and reduce memory leaks as well. And finally, creating containers for specific flows, as you did with the login flow in the previous section, using Dagger subcomponents. So this improves your application performance by releasing objects in a memory when they are no longer needed. And Dagger automatically does all of this at a build time, as long as you declare dependencies of a class and specify how to satisfy them using annotations. So basically Dagger will know how to generate the boring boilerplate code just by adding a simple annotations, and you will see the power of those annotations as well. So Dagger generates code similar to what you would have written manually. Internally, Dagger creates a graph of objects that it can reference to find the way to provide an instance of the class. And for every class in the graph, Dagger generates a factory type class that it uses internally to get instances of that type. So again, you don't need to create those factory type classes anymore. Dagger will generate all of that for you. And at a build time, Dagger walks through your code and builds and validates dependency graph, ensuring that every object's dependencies can be satisfied, so there are no runtime exceptions anymore, so there are no infinite loops as well, and it generates the classes that are used at the runtime to create the actual objects and their dependencies. So down below we can see some examples which are already familiar to us, because we have seen this in the manual dependency injection section as well. So to demonstrate how you can work with Dagger, we're going to create a simple factory for a user repository class, like in this diagram. So down below we can see our user repository class, and basically when we are using Dagger, we just need to place this inject annotation before this constructor keyword. So basically we are telling Dagger to inject those two classes in a constructor of a user repository. So basically you are telling Dagger how to create a user repository instance with the inject annotated constructor, and also you are specifying the actual dependencies which you want to use inside this user repository. So now Dagger knows how to create instance of user repository, but it doesn't know how to create its dependencies. So if you annotate the other classes too, Dagger knows how to create them. So now, as you can see, when using Dagger, you also need to specify this inject keyword on those data sources as well. And with Hilt library, this is even easier. So you will see later. So now we have Dagger components. So Dagger can create a graph of dependencies in your project that it can use to find out where it should get those dependencies when they are needed. So to make Dagger do this, you need to create an interface and annotate it with a component annotation. And Dagger will create a container as you would have done with a manual dependency injection. So inside the component interface, you can define functions that return instances of classes you need, like a user repository, and the component annotation will tell Dagger to generate a container with all dependencies required to satisfy the types it exposes. So this is called the Dagger component, and it contains a graph that consists of objects that Dagger knows how to provide and their respective dependencies. So we have basically annotated this interface named application graph with a component annotation, and by specifying this annotation, Dagger will create a graph of dependencies, and the return type of the functions inside this component interface is what can be provided from the container. So for example, if you create a function named repository and the return type of that function is a user repository, then the Dagger will basically use that return type as a dependency in your application project. So when you build a project, Dagger generates an implementation of application graph interface for you, named Dagger application graph, and with its annotation processor, Dagger creates a dependency graph that consists of the relationships between the three classes, in this case user repository, user local data source, and the user remote data source, with only one entry point, getting a user repository instance. And down below you can see that now we can create the instance of application graph, and then we can just grab an instance of a user repository from the application graph. And down below you can see that Dagger will create a new instance of a user repository every time it's requested. So here, if we check if those two, user repository and user repository number 2, are the same, they will not be the same because they are different instances, and sometimes you might need to have a unique instance of a dependency in a container. So you might want to do this for several reasons. The first one, you want other types that have this type as a dependency to share the same instance, such as a multiple view model objects in the login flow using the same login user data. And the second one, an object is expensive to create and you don't want to create a new instance every time it's declared as a dependency. For example, a JSON parser or even a retrofit instance. So in this example, you might want to have a unique instance of a user repository available in the graph, so that every time you ask for a user repository, you always get the same instance. So in manual dependency injection, you can do this by passing the same instance of a user repository to the constructor of the view model classes, for example. But in Dagger, because you are not writing that code manually, you have to let Dagger know that you want to use the same instance, and that can be done with scope annotations. So we're going to talk about scope annotations even more when we read documentation about Hilt dependency injection library, but here you can see that you can use scope annotations to limit the lifetime of an object to the lifetime of its component. So this means that the same instance of dependency is used every time that type needs to be provided. And to have a unique instance of a user repository, for example, when you ask for the repository in application graph, you need to use the same scope annotation for the component interface and the user repository as well. And you can use a singleton annotation that already comes with JavaX inject package that Dagger uses. So as you can see here, we are annotating our component with a singleton annotation, and classes annotated with this annotation singleton are bound to the life of the graph, and so the same instance of that type is provided every time the type is requested. And of course you need to use this singleton annotation on a user repository as well. So with Hilt library, this process is simplified even more. And down below we can see that alternatively you can create and use custom scope annotations as well. And you can see that in both cases the object is provided with the same scope used to annotate the component interface. Thus, every time you call application graph.repository, you get the same instance of a user repository. And after you annotate those classes with a singleton annotation, then when you create those two variables using this repository, and when you try to compare them, they will be the same, okay? So that's the end of this documentation for Dagger basics. I also recommend you to check out documentation down below which says using Dagger in Android apps to get familiar with Dagger even more, so you can make even better and realistic comparison between Dagger and the Hilt library later when we cover Hilt as well. But I'm not going to record the video about this next documentation about Dagger. Instead, I'm going to create a new video about dependency injection with Hilt, so we can get familiar with Hilt library instead. But that can be your homework to check this documentation as well. So I know that this can be a lot of information for you to process, especially if this is the first time you are working with dependency injection. But don't worry, I'm definitely sure that after reading this documentation and when we start implementing dependency injection in our application, everything will make more sense to you, because you will connect this theory and the practice in your mind, and you will finally understand how it actually works. So it is very important for you that you saw how to manually do dependency injection, because only then you will be able to understand how dependency injection libraries actually works, like Hilt and Dagger. And also you will see how Hilt Android library is making our life a lot easier by removing a boilerplate code and basically generating all the necessary code in a background for us. So that will be all for this video. In the next video we're going to check and read documentation about dependency injection with Hilt, and we're going to get introduced with that library. Hello there and welcome back. So in this video we're going to finally start reading documentation for Hilt library. So let's get started immediately. So Hilt dependency injection is a library for Android that reduces boilerplate of doing a manual dependency injection in your project. So doing a manual dependency injection, which we have already seen, requires you to construct every class and its dependencies by hand, and to use containers to reuse and manage dependencies. But Hilt provides a standard way to use dependency injection in your application by providing containers for every Android class, like activity or fragment, in your project, and managing their lifecycle automatically. So Hilt is built on top of a popular dependency injection library Dagger to benefit from compile time correctness, runtime performance, scalability, and Android Studio support. So down below we can see all the dependencies that we need to add in our project in order to use Hilt library. And in some of the first videos of this course I have already shown you my Gradle build files, and you already saw all the dependencies which I have, but still here you can check out and see what the dependencies and plugins and class paths you need to add before you can start working with Hilt. Okay, so here we have a note saying that projects that use both Hilt and the data binding require Android Studio 4.0 or higher. And of course Hilt uses Java 8 features, so you need to add the compile options in your Gradle build file as well. Okay, so let's scroll down below. So all applications that use Hilt must contain application class that is annotated with a Hilt Android app annotation. And this annotation triggers Hilt code generation, including a base class for your application that serves as the application level dependency container. So as we have already seen in the previous examples, we would need to create a new class which inherits from this application class, and we need to annotate that class with a Hilt Android app. And of course we need to add this new class inside the Android manifest file in application tag. I'm going to show you that when we start working on our own application. So this generated Hilt component is attached to application object's lifecycle, and it provides dependencies to it. It is the parent component of the app, which means that other components can access dependencies that it provides. So basically behind the scenes with this annotation, Hilt will generate some code for us. Okay, so let's scroll down below. So once you set up this application class, then application level component is available, and Hilt can provide dependencies to other Android classes that have Android entry point annotation. So here in this example we can see example activity. And if you are planning to inject some dependencies inside this activity, then you should annotate that class with the Android entry point. And Hilt supports following Android classes like application, activity, fragment, view, service, and broadcast receiver as well. So down below we can see that if you annotate an Android class with the Android entry point annotation, then you also must annotate Android classes that depend on it. For example, if you annotate a fragment, then you must also annotate any activities where you use that fragment as well. So Android entry point annotation behind the scenes is generating an individual Hilt component for each Android class in your project, and these components can receive dependencies from their respective parent classes as described in a component hierarchy down below, which we're going to check a little bit later. So to obtain dependencies from a component, you need to use inject annotation to perform field injection in this case. So as you can see, we are injecting this analytics adapter, and this field should have this inject annotation, and the class in which we are injecting this analytics adapter should have Android entry point annotation as well. So to perform field injection, Hilt needs to know how to provide instances of the necessary dependencies from the corresponding component. And the binding contains the information necessary to provide instances of a type as a dependency. And one way to provide binding information to Hilt is a constructor injection. And you should use inject annotation on the constructor of the class to tell Hilt how to provide instances of that class. So if you want to inject dependencies in a constructor, you need to remember to add this inject annotation followed by a constructor keyword. So the parameters of annotated constructor of this class are the dependencies of that class. So in this case, analytics adapter has analytics service as a dependency. Therefore, Hilt must know how to provide instances of that analytics services. So this is a Hilt modules section, and now let's get introduced with those modules. So there is a time when a type cannot be constructor injected, and this can happen for multiple reasons. For example, you cannot constructor inject an interface, and you also cannot constructor inject a type that you do not own, such as a class from an external library, like for example a retrofit. And in these cases, you can provide Hilt with a binding information by using a Hilt modules. And the Hilt module is basically a simple class annotated with a module annotation, and it informs Hilt how to provide instances of a certain type. So unlike Dagger modules, in Hilt you must annotate Hilt modules with install in annotation as well to tell Hilt which Android class each module will be used or installed in. So dependencies that you provide in a Hilt modules are available in all generated components that are associated with the Android class where you install Hilt module. So in our application we're going to also use modules to provide the binding informations to our Hilt library on how to inject and create instance of retrofit builder, for example. So there are two main annotations which are used inside Hilt modules. The first one is binds annotation, and the second one is provides annotation. So first let's start with the binds annotation. So binds annotation is mostly used for interfaces. So consider the analytics service example. So if analytics service is an interface, then you cannot constructor inject it. Instead, you need to provide Hilt with the binding information by creating an abstract function annotated with binds inside the Hilt module. So the binds annotation tells Hilt which implementation to use when it needs to provide an instance of an interface. And down below we can see an example of that. So a return type of a function tells Hilt what interface the function provides instance of, and the function parameters tell Hilt which implementation to provide. So here we can see one example of analytics service, and this is an interface. And you can see that down below we have analytics service implementation, and inside this implementation we are using a constructor injection. And down below you can see our actual module class. So this class is an abstract class, otherwise it can be just an object if we are using some third-party libraries. And this class is annotated with a module annotation to tell Hilt that this class is actually a module. And we also need to use this install in annotation to tell Hilt which component we should use. And in this case, we're using an activity component because our analytics service will be used in activities, but we can also add different components, and you will see more information about those later. And here inside this class we have one function which is annotated with a binds annotation. And here we are basically providing some binding information to our Hilt library. And you can name this function anything you want. And as I already mentioned, the function return type needs to tell Hilt what interface the function provides instance of. So this function provides instance of analytics service, and the function parameter tells the Hilt which implementation to provide. And we have specified here this analytics service implementation from above. So the Hilt module analytics module is annotated with the install in activity component class because you want Hilt to inject that dependency into example activity. So this annotation means that all dependencies in analytics module are available in all of the application's activities. And down below we have another useful annotation named provides, which is used in Hilt modules. And as I already mentioned, interfaces are not the only case where you cannot constructor inject a type. So a constructor injection is also not possible if you don't own the class, because it comes from an external library like a retrofit, OK, HTTP client or a room database, or if instance must be created with a builder pattern. So we're going to use the same example from above, and let's say that we directly don't own this analytics service class. Then we need to tell Hilt how to provide instances of this type by creating a function inside a Hilt module and annotating that function with a provides annotation. So you can see that now this analytics module is an object, and also it has those two annotations, module and install in. But in this case, this function inside this analytics module has provides annotation instead of binds annotation. And here as well, this return type of this function is telling Hilt how to provide an instance of this analytics service. So as you can see, we're using a retrofit, which is an external library which we haven't created. And here we're specifying how we want to provide this dependency to our activity component. Okay, so I know that this can be a lot of information for you to process. If you're first time watching this video, it might be hard for you to understand, but when we start practicing on our own project, you can go back and watch those videos again, so you can understand it even better. So every time you are watching something the first time, you might not get all the information there are. So you need to watch it over again, and I recommend you to watch those videos where we read this documentation after we implement a dependency injection inside our application, so you can go through those information once again, and your eye may catch something that previously haven't. So there are cases when you need to provide multiple bindings for the same type. So for example, if you want to provide dependency for OK HTTP client but with different kind of interceptors, then you would need to basically create two different annotations, and this is an example of that. So here we have an annotation class named auth interceptor OK HTTP client and the other interceptor OK HTTP client. So those annotation classes have this qualifier annotation and this retention annotation as well. So basically with this we have defined two different annotations, and now inside our Hilt module we can define two different functions and with two different annotations. The first one auth interceptor and the second one other interceptor. And here we can define different implementations of this OK HTTP client. As you can see, this one has auth interceptor and this one other interceptor. And then when you want to inject this specific OK HTTP client, you need to also use this specific annotation for that. Okay, so there are already predefined qualifiers in Hilt. And two most important predefined qualifiers are application context and activity context. So for example, if your class needs context of the activity, you can just provide that context with this activity context annotation, and this activity context will be automatically injected in your class, because this is a predefined qualifier. Okay, so we're going to pause for now, and we're going to continue reading this documentation in the next video, because I don't want to make this video 20 minutes long. So in the next video we're going to continue reading this documentation about Hilt, and you're going to get introduced with component scopes, component hierarchy, default bindings, and some more interesting features of Hilt library as well. Hello there and welcome back. So in this video we're going to continue reading documentation for dependency injection with Hilt section, and we're going to continue from the last time, and now currently we are at this section about generated components for Android classes. So basically for each Android class in which you can perform field injection, there's an associated Hilt component that you can refer to in the install in annotation. So each Hilt component is responsible for injecting its bindings into a corresponding Android class. And Hilt provides you with the following components. So here we have application components, which is actually injector for application. Then we have activity retain component for a view model. Then we have activity component for activity, then fragment component for fragment, then a view component for view, then this view with fragment component, then a service component as well. So here we don't see any broadcast component, and Hilt does not generate component for broadcast receivers because Hilt injects broadcast receivers directly from application component. So Hilt automatically creates and destroys instances of generated component classes following the life cycle of the corresponding Android classes. So if we are using application component, then instances of generated component classes will be created in onCreate method of application, and it will be destroyed at onDestroy method of our application. Then if we use activity retain component, instances will be created at activity on create and destroyed at activity on destroy. The same goes if we are using activity component. Then if you're using fragment component, then instances are created in fragments on attach method and destroyed in fragments on destroy method. And down below you can see also examples for a view component, view with fragment component, and service component as well. So here is the explanation of why this activity retain component and activity component are here in this table basically the same. So activity retain component lives across configuration changes, so it is created at the first activity on create and destroyed at the last activity on destroy. So down below we have component scopes, and I'm going to create a new video explaining you specifically those scopes, and in that video we're not going to read any documentation, but I'm going to show you some good examples so you can get familiar with those scopes as well. So let's continue reading this documentation for component scopes. So by default, all bindings in Hilt are unscoped. So this means that each time your app requests the binding, Hilt creates a new instance of the needed type. And in the example, every time Hilt provides analytics adapter as a dependency to another type or through field injection, Hilt provides a new instance of analytics adapter. However, Hilt allows a binding to be also scoped to a particular component. So Hilt only creates a scoped binding once per instance of the component that the binding is scoped to, and all requests for that binding share the same instance. So down below we can see a table of scope annotations for each generated component. So for application component we have a singleton scope. For a view model we have activity retain scope. For activity we have activity scoped. For fragment scoped. For view scoped. Here view scoped as well. And for service scoped. So as I already mentioned, I'm going to create a new video about those component scope, but still let's continue reading this documentation. So in this example down below you can see that analytics adapter is using activity scoped component. So Hilt provides the same instance of analytics adapter throughout the life of the corresponding activity. So basically that means that this dependency will live as long the activity in which this class is injected in. And before we finish up this video, I want to show you one PDF file which I found on the internet. And here you can see Hilt and Dagger annotations and their usage and some code samples as well. So we can kind of recap what we have seen so far in the Android official documentation about dependency injection with Hilt. So this PDF will be available for you to download in this course as well, so don't worry. So first we have a Hilt Android app annotation, and this annotation basically starts the code generation for a Hilt library, and every application class needs to have this annotation, like we already saw earlier. Next we have an Android entry point, so this adds a dependency injection container to the Android class annotated with that. So for example, if we are planning to use a field injection inside some of the activities, then we need to annotate those activities with Android entry point. So Hilt can actually add a container for this Android class. Next we have inject annotation, which is used both for constructor and field injection. And for the constructor injection, it basically tells which constructor to use to provide instances and which dependencies the type has. And for the field injection, it basically populates fields in the Android entry point annotated classes, and those fields cannot be private. Okay, so down below we can see one new annotation which we haven't seen so far, but we're going to see this annotation in our course when we try to inject our view model. So this view model inject is basically telling Hilt how to provide instances of architecture component view model, and with this annotation we are going to be able to directly inject our view models. So on the right side you can see some examples, and you can see also that we have here this assisted annotation in which we can handle a saved state. Next we have a module annotation, and we are annotating classes with this annotation when we need to add bindings for types that cannot be constructor injected. Then we have install in annotation, and inside this annotation we are specifying the actual components. Then down below we have provides and binds annotations. So provides is used for the classes that cannot be constructor injected, and the return type of the function is the binding type. The parameters are dependencies. Like you can see here, we are providing analytics services. Like in this example you can see that, and in this function you can see that it has a return type of analytics service, and this return type is basically a binding type. So that's how we are telling a Hilt library, and the actual parameters inside this function are the dependencies. And every time an instance is needed, the function body is executed if the type is not scoped. Then we have a binds annotation, which is basically used for interfaces. So methods must be in a module, binds annotated methods must be abstract, so return type is a binding type and parameter is an implementation type. Then we have down below scope annotations. With those scopes we are scoping our objects to a container, and the same instance of a type will be provided by a container when using that type as a dependency for field injection or when needed by containers below in the hierarchy. And I'm going to talk about those scopes in the next video in more details. Then we have some predefined annotations here for application and activity context as well. And at the end we can see this entry point annotation, which is used for classes that are not supported directly by a Hilt or cannot use Hilt. So this PDF file will be available for you to download in this course, and that will be all for this video. And in the next video I'm going to explain you component scopes in more detail. Hello there and welcome back. So in this video I'm going to talk about the component scoping in more details. So as I already mentioned in the previous video, by default all bindings in a Hilt are unscoped. So this means that each time your application requests the binding, Hilt will create a new instance of the needed type. So for the example, we're going to take this analytics adapter. So for example, every time the Hilt provides this analytics adapter as a dependency to another type or through a field injection, then Hilt will provide a new instance of analytics adapter, because at the moment this analytics adapter is not scoped to any component. So here I'm going to show you a table with all the scopes and corresponding components. So there are 7 different scopes which we can use in a Hilt library. The first one is a singleton, which is bound to application component. Then we have activity retained scope, which is bound to activity retained scope. Then we have activity scoped, which is bound to activity component. Then a fragment scoped to a fragment component, then a view scope to a view component, then a view scoped again to a view with fragment component, and finally service scoped, which is bounded to a service component. So let's improve this example by adding activity scope to analytics adapter using this activity scoped annotation. So by annotating our class with this annotation, Hilt will provide the same instance of analytics adapter throughout the life of the corresponding activity. So this instance is bound to an activity now because it is activity scoped, and that means that this instance will be created when the activity is created, and it will be destroyed when the activity is destroyed. Okay, so there is one more important thing to note, And scoping a binding to a component can be costly because the provided object stays in memory until that component is destroyed. So for example, if we have many bindings which are scoped to application component, then those instances will stay in memory all until the application is destroyed, and that can be costly if you have many bindings that use this application component. So now I'm going to show you one image of a component hierarchy, and you can see that on the top of this hierarchy we have application component, and then down below we have activity retained component, which is basically a view model. Then we have a service component on the right side. Then below activity retained component we have activity component, then below that fragment component and view component, and at the bottom we have a view with fragment component. So why is this hierarchy important? So it is important because in our previous case we have annotated our analytics adapter with activity scoped, and that means that that exact binding is available only in below layers of this hierarchy from activity component. So for example, our analytics adapter is available in activity component, in fragment component, in a view component, and in a view with fragment component, but it is not available in activity retained component, service component, or application component, because those components are on the top of the hierarchy and the activity component is below those three. So you need to be careful when defining different scopes with your bindings. So for example, if we use application component or singleton annotation on our adapter analytics, then that binding will be available in a whole component hierarchy because it is defined on the top of the hierarchy, and all childs below that will be able to get access to it. So by default, bindings in HILT are unscoped, so they are not part of any component and they can be accessed throughout the entire project, and a different instance of that type will be provided every time it is requested. And when you scope a binding to a component, it limits where that binding can be used and which dependencies the type can have. So you need to be careful when you are scoping your bindings. And now I'm going to show you an example of manual scoping without a dependency injection library, just by using an Android framework. And after that I'm going to show you again an example of using scopes with dependency injection library like HILT. So here in this example we see one activity, and inside that activity we have basically initialized our analytics adapter, and this analytics adapter variable is scoped to example activities lifecycle, which means that it will be the same instance as long as the activity isn't destroyed. So if another class needs to access this scoped variable for some reason, they will get the same instance every time too. And when a new instance of example activity is created, for example when a configuration change occurs, then a new instance of analytics adapter will be created. And this was an example of manual scoping, so you can see that it's very simple and it's not complicated at all. And now this is the example of scoping with dependency injection library HILT. So now our analytics adapter has this activity scoped annotation. So basically this is the same example as before, but this time we are using dependency injection library to actually scope our analytics adapter. So every time example activity is created, it will hold a new instance of activity component dependency injection container that will provide the same instance of analytics adapter to dependencies below it in the component hierarchy until the activity is destroyed, of course. So every time there is a configuration change, you will get a new instance of analytics adapter. So now you might wondering how can we have a same instance even if there is a configuration change in our activity? And we can have a same instance by using a different scope, in this case activity retained scope. And now basically we just change this annotation from activity scoped to activity retained scope, and we just inject this analytics adapter inside our activity. So now every time there is a configuration change, we are going to get the same instance of analytics adapter, and a new instance will not be created every time like before. And that example was without viewModel class, but if you still want to keep viewModel because you need to perform some logic, then you can use HILT to provide viewModel dependencies using viewModel inject annotation. And the previous example was without view model class, but if you want to keep a view model class because you need to perform some operations, then you can use a view model inject annotation. And basically with view model inject annotation you can inject this analytics adapter without annotating analytics adapter with activity retained annotation, because this view model inject annotation will handle everything and you would not need to create view model factory as well, so everything is handled in the background. And there you go. So component scoping is not complex at all, it's very simple, and I think that now you should be able to understand how it works and how you can manually do it. So that will be all for this video. In the next video we're going to start implementing dependency injection library HILT in our application.